Okay, the next thing we're going to do is properties of inverse function. This is actually mirrored from, let me go back to our very first page of properties. This first portion, f prime of x, f inverse times f of x is equal to x for every x in the domain, and vice versa. F of f inverse of x is equal to x. So this is f inverse of x is equal to x, and also the f of f inverse of x. So that is what we're looking at with trig functions defined here. So these properties, so this first one is your sine of inverse of x times the sine x of x, and sine of sine inverse of x is equal to x. So this is with your sine values, and of course when we're working with sine inverse first, that's the outside function, we have the right side of our unit circle. For the cosine inverse being first, we have the top portion of our unit circle. Think of those highlighted things that when we talked about them earlier. And when we have tan inverse, it was the right portion of our unit circle again. Okay, these are just the basic sine functions. So sine is from -1 to 1, cosine is -1 to 1, and the tangent function was infinity to infinity. So, but what we want to see is when you take the sine inverse of sine of x, you're just going to get x. So we're going to apply these properties and some different trig functions on these next few examples. Okay, so this is just our first example. Cosine inverse of the cosine of 5 over 6, and we want to calculate that. So if I look back to the previous page, cosine inverse, that's going to match this one right here. Well, it just says our answer is equal to x. Well, what is the x in our particular example? 5 pi over 6. So the answer is just 5 pi over 6. And if you want to think about it like we do addition and subtraction, the inverses undo each other. We have, this is going to leave us with 5 pi over 6 if this value is in our cosine inverse region, which is what? The top portion of our unit circle. So is 5 pi over 6 in our highlighted region? Yes, so that gets to be an answer. What about the next example? Okay, so we have cosine inverse 0.2. We look back, that property with the cosine first is just equal to x. Well, we'll go look at the x value. We just have to make sure it's in this interval, because so the answer is just 0.2, just the x value, but that is if this answer is in the range for cosine, which is regular cosine is just from -1 to 1. So is 0.2 in that region? Yes. All right. Okay, so now we have cosine inverse, cosine 5 pi over 4, so where it says it equals to the x value, which would be 5 pi over 4, but that's only if 5 pi over 4 is in our top region, right? Remember, from 0 to pi, that's where it's defined. Now, is 5 pi over 4 up here? No, but where is 5 pi over 4? Down here. What is the cosine value for 5 pi over 4? Negative square root of 2 over 2. So can I find an angle up here that has that same cosine value, but that's in our region? Yes, so what angle would that be? It looks like 3 pi over 4. It has that negative square root of 2 over 2 for the cosine value. So that means my answer, I could rewrite this as and say that that is equal to the cosine inverse of the cosine of 3 pi over 4, because this is in my region, and our answer would just be the x value of that, which is 3 pi over 4. Okay, let's do one more. So cosine inverse, it's just going to be the x value, which the answer would be 2, but since this outside region is cosine, it's going to be from -1 to 1. So 2 is not in the interval from -1 to 1, so in this case the answer is just undefined. And there's nothing I can do to get it in that interval, so there's no other location, so this is just undefined. Well, let me see if I can write that a little neater. So this is just undefined. Okay, next we're going to give you 3 examples. I want you to write them down and attempt them on your own. But keep in mind that this is like order of operations. You do the inside first and then the outside last. So we can see why this outside determines our region for our solution. So that's why this is the top half of the circle from 0 to pi. And this one is going to be from -1 to 1. So keep that in mind as you're doing these next 3 examples. Okay, here's your 3 examples. Jot these down and then pause it and try your hand at this and then we'll check our answer. Okay, on the first one, cosine inverse, cosine of 8 pi over 9. So the answer is just the x, which is 8 pi over 9, but we just need to make sure that this falls in this highlighted region, which this is from 0 to pi. Now don't be confused by this. Remember that 9 over 9 pi would simplify to just pi. So we can see that 8 pi over 9 is in the region. It's not on our unit circles, but it's still in that region. So don't let that confuse you just because it wasn't on the unit circle. It still is between 0 and pi. And it helps to see that with the fraction. So that's okay. That's just our solution. Now, we want to look at sine of 3 pi over 4. So because of this property, the answer is just 3 pi over 4. But we go look in sine inverse region. Remember, that's just the right portion of this graph. Okay, is there a 3 pi over 4 in this right half? No, there's not. But 3 pi over 2, what's the sine value? Square root of 2 over 2, right? So is there a value, a sine value, that's the same as that is in our highlighted region? What is that? Pi over 4, right? So basically we can rewrite this as, let me erase this. Sine inverse of sine of, what did we say? Pi over 4 is equal to pi over 4. Okay, so that will be our solution there. Okay, now let's look at 18. Cosine inverse, so we would just get our x value, which is 1.3, but now we got to ask ourselves, is this value in the region, since it's just our cosine value, which is our normal cosine parent graph, -1 to +1? No, this is outside, so what do we say about this? Undefined. Good. So I'm just going to put UD this time, undefined. Okay, our next examples are going to be solving equations, finding an exact solution when we have a trig inverse function. Now we want to keep in mind that our goal is to get x by itself. So we want to solve for x equals. The first thing we want to do is what? Divide both sides by 3. Whatever you do to one side, do to the other. And that would give us sine inverse of x, don't need a parenthesis, is equal to pi over 3. Okay, now we got to get x by itself, so that inverse over there is in the way. Our method for this is if I multiply this by sine, okay, whatever you do to one side, you do to the other, so I'll multiply this side by sine. Now what happens when you have sine inverse x? That's our property, right? What is the answer? Just x. So we would just get x is equal to the sine of pi over 3. Okay, now we can actually use our unit circle to calculate this. So the y value at pi over 3, you go to pi over 3, the sine of that is going to be x is equal to the square root of 3 over 2. Okay, this is our next one. I'll write it down and then pause it, and you can try this one if you'd like. Okay, the first thing we want to do is to get x by itself, so we're going to divide both sides by 12. So that would give us tan inverse x is equal to 3 pi over 12, just simplifies to pi fourths. Okay, good. Now what can we do to get x by itself over here? What property can we use? Good, multiply both sides by tan. Whatever you do to one side, do to the other. And then tan inverse of x is just x. From that property, x is equal to the tan of pi over 4, which remember your tangent is your sine over your cosine, so pull up your unit circle. And what's that value going to be? Go to pi over 4. What's the y? Yes, that's nice because those are square root of 2 over 2 divided by square root of 2 over 2. So our answer is just x equals 1. Okay, good job there. Okay, this is our last one. Go ahead and write it down and try it. We're going to go ahead and proceed. So the first thing we're going to do is divide both sides by 4. Divide by 4, divide by 4, and that would just give me cosine inverse 3x is equal to, dividing by 4 is multiplying by the reciprocal. Or actually, that's just going to give us, let me go back. I wrote this problem down wrong. So this is 3 pi. That's what I did. I had already shown that I had divided by 4. So the original problem was just a 3 pi. And then now when we divide both sides by 4, we will get 3 pi over 4. Got ahead of myself there. So 3 pi divided by 4. Okay, so the original problem is in black. All right, now what do we do to get rid of that cosine inverse? Multiply both sides by the cosine. Whatever you do to one side, do to the other side. This property right here would just give us this value, which this time actually is a 3x, is equal to cosine of 3 pi over 4. Okay, let's go evaluate this first. Cosine at 3 pi over 4 is right here. The cosine value is negative square root of 2 over 2. Okay, so we evaluate this and we just bring down that. So what do we do to solve for x? Divide both sides by 3, or that's the same thing as multiplying by the reciprocal. Divide both sides by 3 or multiply by the reciprocal. That would give us x is equal to negative square root of 2 over 2 times 3, which is just 6. And that would be our solution.